Hi everyone. Mhm. My name is Ivan, and today we are going to talk about testing. What is it? What kind of tests do we have, and why you, as a software developer, software engineer, should write different tests? I'm a Java senior software engineer. I have been working in Japan for 3.5 years now, and all this time I'm writing different kinds of tests. So let's start with this diagram. Using this diagram, I want to show you that testing allows projects save time and money because bugs are cheaper and easier to fix before they go to production. Why it's cheaper and easier? Because in case some edge case, corner case will be found in production, there should be a lot of actions to roll back previous release, to redeploy stable version, and so on, so on. So I think that is why finding bugs during testing phase is cheaper and easier, really. And I want to talk about testing from continuous integration perspective. What is continuous integration? For me, it is a concept, maybe methodology, how your changes can be integrated into one big software project as fast as possible. Let's say you are working on some feature and continuous integration includes different steps. Let's say you are done with your feature and you are creating pull requests into master, and your team somehow needs to verify, needs to be sure that your feature is working. So when you are creating pull requests into master, some build should be triggered. It can be, for example, Gradle build. And during this Gradle build, some tests needs to be executed, and this test will verify that your small, simple piece of code, additional code, is working correctly. Let's say build is successful. Your PR can be merged. After it is merged, there should be a special deployment pipeline which is able to deploy your changes into, let's say, test environment. But before it is deployed to test environment, a lot of tests, different tests should be executed to verify that your changes will not broke already existing and already correctly working flow. So let's talk about these different kinds of tests during continuous integration. Today, I want to talk about 3 basic types of functional tests. First of all, let's talk about unit tests. Unit tests verify individual piece of source code. Since we are talking about Java, it can be a class, it can be a method inside the class, and your unit test should verify that class behaves as expected. Next level of testing is integration tests. If unit tests are verifying small piece of code, integration tests are verifying how these small pieces are working together. During integration testing, you can just call some API and check response code, check response body, and that's it. You just want to be sure that the whole system, which consists of small components which are already verified by unit testing, they as a group are working as expected. And the next level of testing is end-to-end tests. They are checking some use cases, they are checking some business flows, which are important from the client perspective. From my point of view, end-to-end tests should start with UI. Let's say you clicked some buttons on UI and it triggers some flow, and during this flow, all components which were already tested using integration tests, they will be like tested again, but let's say end-to-end test verifying the whole system, not from the just working perspective, but from the user's perspective. Okay, so 3 huge types of tests, and let's talk about first type, unit testing. For me, key points of unit testing are the following. First of all, it verifies, as I said earlier, it verifies small piece of code. And how it verifies only small piece of code and not the whole system? Well, it uses mocking. What does it mean? Let's say you are developing some service, and this service is able to call database. When you are creating unit tests, you should not call database, because we are actually checking how your service behaves. Your service can behave incorrectly if database behaves incorrectly. But as I said, that is why we are using mocking. We mock all external dependencies and just checking your component, your piece of code. That is why unit tests are actually fast. Since we are not going to interact with some external systems, just advantage of this approach is that they are actually fast. And the last point which I want to mention is that they are actually isolated. What does it mean? Unit tests are isolated. It means that if one unit test is failing, if your tests are, let's say, designed correctly, it should not cause the failure of some other unit tests. All unit tests should be independent. Okay, so we have talked about unit tests. Now we have some basic understanding, and let's check the real code. How unit tests look like. I have created a couple of entities, a couple of services to show you how unit tests can be created. Let's say we have a booking system. We have hotel and we have a lot of hotel rooms. Hotel room has ID, has number, has size and cost. Okay. What else do we have? We have customer. Customer has also customer has ID, customer has first name, last name, and some budget to order some room. And finally, we have booking. Here we also have ID. We have what information do we need? We have hotel room, we have customer, and we have start date and end date for this booking. Okay, we have checked our entities. Let's check our booking service. So my interface has just one method, book. It should return false if booking was not successful and return true if it is successful. For booking, we need just 4 parameters: hotel room ID, customer ID, start date, and date. And we have one implementation. Let's walk through this implementation. Let's start with our dependencies. As you can see, for booking, I need to have these classes. We have 3 repositories which are actually interacting with the database: booking repository, hotel room repository, and customer repository. And we have a special validator, booking validator, which can check some business cases of our booking. So we have a constructor where we inject all these components, and let's walk through our book method. First of all, we are checking that incoming IDs are correct. We want to find a hotel room by that ID. If hotel room is not found, we are throwing hotel room exception, because without proper hotel room, we just can't create booking. Secondly, we also want to find customer. If customer is null, again, we just can't create booking. We are throwing customer exception. If customer and hotel room are found, we finally can create booking. But booking can be invalid. How it can be invalid? Let's say, I don't know, end date is before start date. This is totally invalid. What else it can be? Let's say customer, as you remember, it has budget, right? Let's say budget is lower than a hotel room price. In this case, also, booking is invalid. But all this logic should be inside validator, and validator just returns true or false. And if this is false, then we throw in validation exception, and the booking won't be created. Finally, if all our checks are successful, we are trying to call database to actually create booking. It returns true if booking is created. If it is created, then we should perform additional call to update cost, to update customer budget actually. And we return this variable, is booking created or not. So we have checked all our method, and now our task is to create unit tests. So what do you think? How many unit tests should we write for this method, for all this logic? So maybe you're rendering just one, just to check happy pass. Well, let's check. So I have created unit tests for this book method, and I decided that I need to create 5 unit tests for such method. Let's start from the beginning. As I said, unit tests are using mocking, and we have special library which is called Mockito. How does it work? We can add a special mock annotation to all our components which should be mocked. What does it mean? What is mock? Mock is a special object which is not able to do anything by default. So if you are using validator mock and you are calling validator.isValid, it will return it just can't really validate this method. Okay, so here in setup method, we are injecting all these mocks into booking service impl. So important thing here, we are not using actual repositories, actual validators. We are just using mocks, and by default, mocks can't do anything. So we need to tell these mocks what should they do when they are called. Let's check the first method. First of all, test annotation is required. As far as I remember, return value should be void every time, and test method is also should be meaningful. For example, here test method name is should create booking. So I assume that it is a happy pass, that booking should actually be created and no exceptions should be thrown. Okay, so let's check. Using when method, which is actually from a Mockito library, we can tell all these components what should they do. For example, when we call repository find method, it should return hotel room. This hotel room, not some hotel room from the database. There should be no actual calls to the database. Same thing for customer repository. Just return this new customer and that's it. When we are calling validator is valid method, just return true. We are assuming that our booking is valid. And when we are calling create booking method, also just return true. We are assuming that booking is successfully created. So using this approach, we can just check how our service actually behaves internally. We are checking how it behaves based on what these components return. Okay, so here we are actually calling our booking service .book with some parameters, and we're checking what it returns. It should return true. We are checking that actual variable is true. And as the next part is also very important, I would say. Here we are checking that all these methods were called. So we are checking that hotel room repository dot find was called, because it should be called if booking was created. We're checking that customer repository.find was called, and so on, so on. And one more important thing is here we are checking that there were no interactions for all these components, just these interactions. Well, I hope that it is clear how to create happy path test. Now, let's walk through negative test cases. Here, test method name should throw hotel room exception. I assume that this method should cause, this test should cause hotel room exception. Let's see. When hotel room repository.find, we should return null. It means that we were not able to find this hotel room in our database. Okay, so using this assert method, we are actually checking that booking service.book method would throw hotel room exception. This assertion will fail if, for example, I would place here customer exception. It should be just hotel room exception. And the important thing here, if hotel room was not found, these components should not be called. Customer repository should not be called, validator should not be called, and repository should not be called, because inside book method, hotel room check is first. So we should throw this exception, and all this logic just shouldn't be executed. So, okay, so I hope it is clear. Hotel room exception case is covered. Next test should throw customer exception. Well, it's basically the same. We are assuming that hotel room is found. So hotel room is okay, but customer was not found. So we are expecting customer exception. And as you can see, we are verifying that hotel room repository was called and everything was successful. But since customer exception was thrown, booking validator and the booking repository were not called. So this case is also covered. Next case, validation exception. So this time, hotel room and customer were found, but unfortunately, our booking is invalid. We should return false. So again, we are checking validation exception. Validation exception should be thrown. We are checking that these repositories were called, no interaction for booking repository, and no interaction for update customer budget. And the final test case, it's when booking was not created. So everything was fine, but yeah, maybe database is down or something else, and that is why booking was not created. It returns false, and yeah, we are asserting that our method return false. We are verifying that all these components were called, and that's it. So that's it. Maybe now you are looking into this method and you can see more negative cases, more edge cases. Maybe, but yeah, I don't see them. That is why I wrote just 5 unit tests for all negative and positive cases which I can see. Okay, so I described all the cases, but let's finally run them. Okay, so here we can run booking service test, and as you can see, all tests are green. So if we would change something, let's say here, we are expecting customer exception instead of hotel room exception, right? Let's run. And as you can see, should throw hotel room exception method, expected customer exception, but actual hotel room exception. So as you can see, as I said, only hotel room exception is expected here. One more thing which I want to show you is test coverage. Here we can select run booking service test with coverage. Okay. And if we go back to our booking service info, you can see green lines here. Green lines mean that these lines of code were executed during our tests. So in a perfect world, all your lines of code should be green, but yeah, I would say this method is pretty straightforward, and on production, there can be much more complicated use cases that just can't be covered properly. So that is why all projects have different thresholds for testing. For example, I don't know, class coverage should be 100%. Method coverage should be maybe 95%, and line coverage should be 90%. So different thresholds for different types. Okay, so I think that's it for demo. I showed everything what I want. Let's go back to our presentation. So we looked into unit tests. Now let's talk about integration tests. So let's say we have our booking service, and booking service in our case is a small piece of code. When we're talking about integration tests, we will not mock database. We would actually call database and check that this booking service actually returns true with all validations, with all database calls, etc., etc. I think it's totally understandable that since we are actually calling some external services, external components, integration tests are slower than unit tests. And integration tests should be run during deployment. So if you remember our continuous integration steps, during build, I would say unit tests should be executed since they are fast and they are just checking small pieces of code. And during deployment, integration tests should be executed. One more important thing here is that they are not isolated. I said earlier that unit tests are isolated, so integration tests are not isolated. I can imagine the case when one integration test can cause the fail of another integration test. There are some best practices which can avoid such behavior, but in general, I would say that integration tests are not isolated and they can cause domino effect. The last type of functional test which I want to discuss is end-to-end testing. End-to-end testing is a methodology used for ensuring that applications behave as expected. Let's say we have some business flow which requires interactions between, I don't know, 10, 11 services and 5 databases. And you update just one of them, just one service of 10. Well, we should run end-to-end test and check whether your update caused some bugs or not. So I would say end-to-end testing, maybe it is more related to continuous delivery principle and not related to continuous integration. There is a difference between these two concepts, continuous integration and continuous delivery. And continuous delivery is related to constant ability to deliver something to production. So using end-to-end testing, we can be sure that all our important user scenarios are well tested, well covered, and etc. Okay, so during all this presentation, I actually described this concept, which is named testing pyramid. Basic level, unit testing. It actually checks just your code and your logic. Next level, integration testing. It checks interaction with databases, with some other services, APIs, but it also checks code and logic. And the final point is end-to-end testing. It starts with UI, and since it is calling all our services, it also checks databases, services, code and logic. And here I want to discuss what you should do as a developer. I'm 100% sure that you as a developer should write unit tests. Since you wrote all your code, all your business logic, you know this code. You know this code and you know some corner cases, some edge cases, which some other developer simply will not know. What about integration testing? Well, I would say that it depends on the project. I know some projects where developers should also write integration tests and maybe even end-to-end tests. But also there are projects where we have special QA teams, and these teams are responsible for integration testing and for end-to-end testing. So yeah, it really depends. But be prepared for the case when you, as a developer, should write unit tests, should write integration tests, and maybe even end-to-end tests. Well, just want to summarize, which I described previously. During continuous integration, we have a lot of tests. During build phase, unit tests should be executed. During deployment tests, actually, there will be a lot of tests executed, functional tests, non-functional tests. But I know for sure that during deployment, integration tests should be executed, and only after integration tests are 100% complete and are 100% successful, your code should be deployed to test environment, and let's say only after that it can be released to production. And
Okay, I think Ivan has some internet issues. Maybe he will join us soon. Maybe he will reconnect. I think he almost finished with his lecture, so I think we can go to Q&A session. I will try to answer all your questions. Well, unfortunately, Ivan isn't here right now. So the first question was about using random in unit tests. As far as I understand, if method which I want to test is using random and I write a test for this method, it's not a unit test, but it's an integration test. I haven't heard such things. I know that using random in unit tests is highly discouraged because your unit tests are not repeatable. If you run your unit test, it fails, you may run it again and it will succeed because, well, some random values were generated another way. It's not a good approach for unit tests. So unit tests should be repeatable and they should not use random because of it. But does it make them integration? I think not, but maybe it's kind of controversial. The second question, should we test only the contract, only interface methods or internal logic as well? For example, in should throw customer exception, we also check sequence of the calls inside book method. That 3 methods were not called. In case we change implementation, our tests might fail. Yeah, exactly. That's exactly the point of unit tests. There are 2 different types of tests. First is what's it called? White box, and second is black box. Black box testing is a testing of the interface, so you don't know how the system works internally. So it's like a black box on the planes. Yeah. Unit tests, on the contrary, are white box tests usually, so you know the internal implementation and you may rely on the internal implementation. If your unit tests break, it's not a bad thing. Vice versa, it's a good. You find a bug, probably you find a bug. So yeah, in unit tests you should test internal logic as well, but in integration and end-to-end tests, probably not. And the last question that I see so far, you can ask more right now. Question, what do you think about TDD? TDD is test-driven development. It's a practice when you first write unit tests and then you write code that passes these tests. Well, TDD is considered a good practice nowadays. It helps you to develop more maintainable, more testable code. Maybe it's a bit slower than, well, usual development, but still it's good. If you can do it, then definitely you should. And if you would like to read more about it, I think there are several books on TDD. One of them was written by Ken Beck. It's, well, one of the best. Okay, I will give you 1 more minute to ask a question, and now I will ask you to go to We Are Community platform and rate today's talk. It will help us do better talks the next time. Okay, I don't see any more questions. Thanks for your feedbacks, and see you guys next week. Bye.